In this topic, we are looking at control plane protection. So this is essentially an enhancement of control plane policing, and it allows us to be able to have 3 different sub interfaces to be able to apply things like traffic classes and traffic policies to each of these sub interfaces. So it allows us to be much more granular than control plane policing. A couple things that we need to remember is that control plane policing is supported on some devices where control plane protection is supported on a variety of other devices. So we have a couple charts that you can always refer to be able to see where this might be applicable. So a couple things to remember is it allows us to have those multiple queues or those multiple sub-interfaces. We can automatically separate things like our host terminated traffic versus our transit slow data plane traffic. So the 3 types of sub-interfaces that we see here, host, Ceph, and non-Ceph, are some examples. So essentially, when we look at that concept of host, that's going to be our control plane host. That allows us to receive all control plane traffic destined for the routed interface. So when you think about things like management traffic, SSH, SNMP, IBGP, tunnel interfaces, EIGRP, that is a very essential sub interface. It's very, very critical for us to protect this traffic. And in addition to some of the things that we'll be looking at, if your device doesn't support just control plane protection, make sure that you're adding control plane policing or any type of port filtering or anything else that we can possibly do to try to protect that. So the Ceph and the non-Ceph, these are classified under our slow data path processing. So transit or non-Ceph is any traffic that is software switched by the route processor. So any traffic that's not directly destined toward the router, but that's traversing the device. So thinking about traffic that's going through the device instead of to the device. Next, we have Ceph or Ceph exception. This is where traffic either is redirected due to configured input like OSPF, EBGP, LDP, or even when we think about input queues such as ARP and things like that. So those are some examples. Next, we're just going to talk about a scenario where we might implement this. Here we have some EIGRP traffic that is directly connected in the 10 subnet. We'll have all of those peers in that 10 subnet, and we want to limit them to basically produce no more than 200 packets per second, and all other traffic for the control plane should not produce more than 50 packets per second. So here's a quick config. We can see the first step is configuring the access list. So it's an extended ACL specifically for EIGRP traffic, and we can see we're matching on that 10/8 destined for anywhere. Now, the class map is just going to be referencing what we're doing in the first step. So you need to ensure that whatever class map you've created, in this case, CPR EIGRP class, is matching the access group that we created in that first step. So we just have to make sure this matches this. All right, so that's step 2. Step 3, we're creating the policy map. If any of you are familiar with route maps, policy maps, similar concept. We have if and then statements, but instead of if and then, it's going to be a match and a set. So anything that we want to sort of match on, we have the ability to either permit or deny, or in this case, we are going to be dropping traffic. So we create a policy map called CPR policy. It's referencing the class map that we created in step 2, so we just have to make sure that matches. And then we're basically saying if it matches that class map, then what do we want to do? So we're going to be rating it or rate limiting it to 200 packets per second. And in the event that we exceed, we just want to drop that traffic, all right? And we also have an example of a rate limit for 50 packets per second. Again, we are going to be dropping it if we exceed that action. So that was step 3. And then the very last step, which is step 4, is associating it or tying it to one of the 3 sub interfaces. So in this case, we are tying it to the control plane host sub interface. And of course, we definitely want to make sure that after we've kind of brushed up on these commands, so what is it that we want to specify as far as the access list, what type of traffic class is going to reference the access list. This is, just reviewing the previous steps, creating the traffic policy, and then applying it to the policy map. But we also want to know how to verify. So there are some examples in the courseware on verification. Make sure you skim through that if you're not already familiar with how to set this up. And here they give us an example of the show policy map control plane all. We have a little bit of the output here. There's a little bit more output in your courseware, but you can see the show policy control plane all is going to tell us the input policy, what the name of the class map was, and here is the access group that we were matching on. All right, so the then statement was, what are we policing, 200 packets per second or 50 packets per second, so on and so forth.